Hello students, welcome to video lesson 4.5. Today we're talking about another special kind of four-sided shape called a trapezoid. This one is not a parallelogram like we've been looking at in our past couple of videos. A trapezoid is actually a quadrilateral that has only one pair of parallel sides. We've been talking recently about parallelograms and then specific parallelograms that have two pairs of parallel sides. As I said, in today's section, we're talking about trapezoids, which are defined as quadrilaterals with one pair of parallel sides. Those two parallel sides are called the bases of a trapezoid. So there are two bases. You can see them here on the top and bottom, but it doesn't necessarily have to be the top and bottom of the shape. And then the two sides that are not parallel are what we call legs. Okay, so every trapezoid has two bases and two legs, and the legs are not parallel and the bases are parallel to each other. Okay, and then one extra specific type of trapezoid, which may not come up a bunch in your homework, but is important to note. We can have isosceles trapezoids just like we have isosceles triangles, where we have two congruent sides. And specifically in an isosceles trapezoid, we're talking about the legs being congruent. Okay, so if the legs are congruent like this one here, then that is called an isosceles trapezoid. Okay, and there are some extra special things about isosceles trapezoids, like these base angles down here are congruent to each other, and then these angles up here are also congruent to each other. Okay, but beyond that, we're not really going to apply isosceles trapezoids a ton, except maybe in an extra credit question on a test or something like that. Also, as long as we're here talking about trapezoids and sort of special things we know about them, because we know this side is parallel to this side, both of the angles along this leg over here, this one, which I'll call angle 1, and this one, angle 2, they have to add up to be 180 degrees, okay? So one of them has to be bigger than 90 and the other one has to be smaller than 90. The same is true over here for like angles 3 and 4. Same thing. They have to add together to be 180 degrees. So one is bigger than 90, one is smaller than 90. Okay, that should help with a couple of your practice problems. But the main thing that we're going to do in terms of math with a trapezoid is actually something specific called the midsegment of a trapezoid. Okay, so when we have a trapezoid, if we connect the midpoint of one leg, which I have marked right here, the midpoint of that leg, because it cuts that leg into two equal pieces. If I connect that to the midpoint of this leg over here, which cuts that into two equal pieces, I've created what is called a midsegment. Okay, so this guy down here, down the middle, is called the midsegment. And there's a couple things of note about midsegments. Okay, so number one, the midsegment is parallel to both of the bases. Okay, so we know that the two bases, in this case on the top and bottom, those are parallel, right, are one pair of parallel sides for the definition of a trapezoid. And then the midsegment, when we connect the midpoints of the two legs in this manner, we get another segment that is parallel to both of those as well. Okay, so the midsegment is parallel to both of the bases. And it is also true right here. If you double the midsegment, it equals the sum of the two bases. Okay. Another way to think about that is the midsegment length is half of the two bases added together. Okay. So midsegment, forgot the I. Midsegment is 1/2 of the two bases added together. So for example, if we have this base on the top, let's say is 8 inches long, and this base on the bottom, let's say that one is 14 inches long, we can use this idea to find the length of the midsegment down the middle, okay? So we just simply would have to add the two bases together, 8 plus 14, that gets us 22, and then cut that in half or divide it by 2, and the midsegment length must be 11 inches. Okay? So we can use the two base lengths if we know them to find the length of the midsegment. We can also use the length of the midsegment and one base to find the other base. So for example, if I know that the midsegment length is 5 feet, and I know that this top base up here is, let's say, 3 feet, I can figure out what this base length down here is because remember back up here, if you double the midsegment, it equals the sum of the bases. So if I double the midsegment length, if I do 5 feet doubled multiplied by 2, that gets me the sum of the two bases, okay? And in this case, 5 times 2, or doubling that midsegment, 5 times 2 gets me to 10, right? So 10 has to be what my two bases add up to be. One of them is 3, so the question is 3 plus what gets me to 10, and that has to mean that the other base is 7. Okay, so the other base is 7 feet. Okay, another way to do that if you want to, if you just think, how do I get from 3 to 5? How do I get from 3 to 5? Well, I have to add 2, right? So if I do it again, that should get me to the other base. Add 2 and add 2 again. Same would be true if I knew this one, I could go -2, right? So we can use that sort of relationship as well. Just knowing that the midsegment's length is right in between these two bases, okay? So, like I said, the midsegment of a trapezoid is parallel to both of the bases, and it's equal to half of the two bases added together in terms of its length. We create it by connecting the midpoints of the two legs of the trapezoid, all right? And yeah, again, the legs are the non-parallel sides, bases are the parallel sides. We talked about isosceles trapezoids, meaning congruent legs and some of the angles that have to be the same. And yeah, if you have any questions about what a trapezoid is, or any of the questions that they're asking you, your practice problems are interesting. For this section, they make you think a little bit. So if you're having trouble with any of those, please do reach out to me. Otherwise, that's all I have for you right now, and we'll talk to you soon.